Hello everyone, welcome to Chip Confessions. In our previous video, we saw about the arrays, and in this video, we will be seeing about the strings in Verilog. Before that, I just want to explain about the compact and verbose declaration. I just told what are they in our previous video. In this video, let me just explain what are those and we can move on to the strings. So we have something called as compact and verbose declarations. And these two are the ways we can declare the size of an array. What is compact and what is verbose? In the compact, what we will do is we will declare the array with a solid size, like we will just give only one number. If I just give like that, this is called as compact declaration. And in the verbose declaration, we are explicitly mentioning, like for example 3 down to 1. This is called as verbose declaration. We can give it as like 3 to 1. The size will be 3. Like this in compact, and the same will be declared like this in verbose. So verbose is nothing but you are explicitly mentioning from which index to which index you need the array locations, means you are explicitly giving the index numbers in verbose declaration, but in compact you are just mentioning how many locations you need. So in compact, what happens if you just give 10, it will take, like implicitly it will take from 0 to 9, and you can't change this. This is implicit and this will be assigned by the system itself. But what happens in verbose is it will be more customized, means the control or the name of the index, the control of the giving name to the index will be in your hands. You can give 3 down for 3 locations. You can give it as either 2 down to 0, where it will take 2, 1 and 0 for location names, or you can give 3 down to 1, which can take like 3, 2 and 1 as location names. Like that you can give anything. You can give like 5, 4, 3, 5 to 3. So it will be 5, 4 and 3. Means the control or the naming of the index will be in your hands, and whatever the name you give, that will be assigned to the locations. But the thing is, this compact can be given only to the size and not to the width, which means whenever we are declaring an array, for example we are declaring reg, and here we cannot give 10 and name of the array and then some size. You can't give like that. This will be an error. This will be error. So in width it is compulsory that we need to give verbose declaration, whereas in size you can give either verbose or you can give either compact. Anything you can give. This is about the compact and verbose declarations. Now we shall see about strings in Verilog. Verilog doesn't have any built-in type for strings. In system Verilog we have something built-in data types which is called as string, but in Verilog it is not like that. We do not have a string data type in Verilog. Then how we will use strings in Verilog, how we can assign a string value to a variable, that we will see. And before that we shall see what does a string mean. String means anything, any text or any number or any symbol which is mentioned in between two double quotes. You can mention anything inside this. Anything means anything. You can mention a symbol like this, or you can mention any number like this, or anything. You can mention any character also. Anything if you mention within these two double quotes, it is called as string. And the value or the character you mention inside this double quotes will be treated as a text. Means even if you mention 1, 2, 3, 4, anything, even if you mention number also, it will be treated as a text value. So a string is nothing but any value or any character which is mentioned in between two double quotes is called as string value. So as I told, in Verilog we do not have implicit string built-in data type. So what we will do is we take reg and we take the width, and we will declare an array, or means any variable, and we will assign a string value. This is how we do in Verilog. Means we take a reg or we take a reg data type, then we will give the width, and then we will give the variable name, and then we will assign with a string value. This is how we do in Verilog. Then how we can know the width? Simply, like, we can take anything like 30 down to 0, 31 down to 0, or 100 down to 0. No, it's not like that. We can calculate the width based on the number of the characters we use inside these two double quotes. How we can do that? Let us see. We have something called as ASCII values. So this ASCII values will define your character value. Means this ASCII stands for American Standard Code for Information Interchange. What is this? American Standard Code for Information Interchange. You might have studied this in your C language. So what this ASCII value will do? This ASCII will assign unique numerical value to your character, or the value you are mentioning in between your double quotes. So this ASCII is nothing but which assigns a unique numerical value or a unique decimal number to your unique integer to your character, whichever you are mentioning inside the double quotes. So if we just see, whenever we are mentioning any special character, such as if you're mentioning a hash symbol, star symbol, dollar symbol, or any letter like A, B, C, D, capital letter, small letter, square bracket, curly braces, anything including space or a null character, we have a unique number or a numerical value which is called as ASCII value, which is assigned to that character we are mentioning inside the double quotes. So let us see what are those values. If we see those values, we have a table here and you can see the values mentioned. This is the decimal equivalent and this is the hexadecimal equivalent and this is the character. So we have a null character. For that the decimal and hexadecimal values are zeros. Like that only we have something for, we have value for space also, which is 20 in hexadecimal and 32 in decimal. So this ASCII will support 127, means 128 values, means 0 to 127 unique numbers. For that it will allocate the characters. Means ASCII is a 7-bit value, and as it is ranging from 0 to 127, that is the range is 0 to 2 to the power of 7 minus 1. This is the range of this ASCII values. Means for 128 unique characters, it is allocating 128 unique numbers starting from 0 till 127. Some systems even support 128 to 255 also, while including the different characters such as epsilon character, that is different language characters. As we have means by basically we use English alphabets, like small letters we have and capital letters we have, as we see here. For capital letter we have 65 till 90 we have decimal values, and then for small letters we have 97 till 122. But whenever we are going to include like Russian characters will be there, and Spanish will be there, and epsilon will be there, for those kind of things this value will get will be increasing. For basic characters, whatever we use in our convenience, when which are all the characters we use in day-to-day life, or which we use widely, for those things we have 0 to 127, that is for 7-bit ASCII value. Basically we have 7-bit ASCII value. Let us see how we can declare a string now, and we can check by a code that how it will take the values. So whenever we are saying like how we can declare a string, we can take reg and we have to declare the width. For a single character it is just a 7-bit, so you can take 6 down to 0, or for safer side you can take 7 down to 0 also, where your last bit will be assigned with a 0, that is your MSB will be assigned with a 0, and you can take the variable name. So this is how you will be declaring for a single character. This is for a single character or a single value. And while assigning, what we will do, variable is equal to, inside the double quotes we have to assign a character. This is how we do for a single character. This is the declaration. We will take reg data type and we will declare the verbose type of declaration for the width, and then we will give the variable name. And for a single character it's 7-bit is enough, so we are taking 6 down to 0, which counts to 7-bit in total, and then we are taking the name of the variable, and then we are assigning with the character inside these two double quotes. So can we take an array, like vertical array of the strings? Yes, of course we can take, like reg we can take same 6 down to 0. This will be the width of the each character, and we are taking variable, that is the name of the variable, or we can take array here as we are considering array, and we can give it as 10, or means it will take the size of the array will be 10 and it will take 10 values. So this is how we will assign. This is single character, but this is an array. This is just a single character variable. Here we have single character array. So this can take 10 values of single characters. This is how we declare. Okay, let us see what we should do when we have multiple characters. At that time we just have to calculate with 7. Means, for example, we have to give the value a b c d to a variable. What we will do, we will take reg, and here we just have to calculate the width. How we will calculate? For each character it is 7. So 7 into, we have 4 characters, so it is 28. So we can take 27 down to 0, and we can take a variable, and directly we can assign the value. This is ABCD. So this is how we declare the string in Verilog. In system Verilog it is easy. I just want to show, we have something called a string, and you take some variable name and you can assign with any sentence, or means it is like with any length you can assign. But in Verilog, for length of the string you are assigning, you just have to consider with the width of the variable. Means what happens if you are taking a smaller width and if you are assigning a like bigger string, means whenever you are taking a larger width and you are assigning a smaller string, it will not make any difference because the rest of the MSBs will be 0. How it is happening means, I'll just say I'll just give you an example where we are taking a single variable, means a single character we are taking, but what we are doing is instead of 7 bits as we are doing here, what we will do is we will take some 14 bits, like we will be declaring like 13 down to 0, like this we will be taking. So this will be countable to 14 digits. What it will do for a, for smaller a, the value is 97. Is it 97? For smaller a, the value is 97. Yes. Oh. Smaller a, the value is 97. And what happens is after this 7 digits, the rest of the 7 digits will be 0. Like that it will be. Rest of the means this MSB digits will be 0 and this next 7 digits will be assigned with this value. So it will not make any difference. Only your memory will be consumed. Apart from that, nothing will happen. Okay. Then what happens if we are declaring a smaller width and if you are assigning a larger string? For example, you have taken only 6 down to 0, which corresponds to only one character, but you are assigning 2 or 3 characters. Let us say you are assigning ABCD only, but you have declared the width as 6 down to 0. What will happen here? What will happen is this will corresponds only with this LSB. Means this A, B, C, D we have, this is your 6 down to 0, this is your 13 down to 7, 7, 8, 9, 10, 11, 12, 13, yes, and then 14, 15, 16, 17, 18, 19, this will be your 14 down to 19, and this will be your 19 down to 14, this is 19 down to 14, and this will be your 27 down to 20, like that it is. So something it will happen. I'm like poor at calculation here, please don't mind. The thing is, like, it is like that, only 7 bits will be 7 bits it will divide among this, whatever the complete width you are giving here, it will be divided like this. But as you are giving only 6 down to 0, means only 7 bits you are giving, this will corresponds only to the first character. So this ABC will not be assigned, only this D will be considered, and a rest of the characters will not be considered, means those characters will be truncated. This will happen when you are declaring smaller width and if you are assigning a larger string value. Whenever you are declaring a larger width and giving only a smaller string, that does not make any difference apart from your memory consumption. But whenever you are declaring a smaller width and assigning with a larger string, your string will be truncated, and only with the width, whatever it is, whatever that string value can contain, starting from the right side, means starting from the LSB, that much only will be assigned. So let us see the code now, how we can declare and how we can print, and how it will going to print the characters that we shall see with the code here. So what I have done here is I have taken the module. Don't worry about the code, please don't worry about the code. We will be start as soon as possible. We will start coding, and at that time I will teach you line by line. So don't worry about the code. I repeat, don't worry about the code. So you just have to observe what the output is. You just have to understand the flow. That's it. You need not to worry about the code as of now. So let us start with analyzing this code. What is, we have just given the module, a name of the module, and we are ending with the semicolon. As we are not using, or as we are not giving any input or output here, we have not mentioned any ports. So we just have taken the name of the module and we just ended with the semicolon and ending this block with the end module. So module is the basic block, as I have told you in our one of the previous videos. That is the basic block of the design, or basic block of your Verilog code. Without this, your Verilog code is not going to execute at all. So we have a module here, a name of the module here, and we are ending with module block with the end module. Then what we are doing here is we are taking reg and we are taking 7 down to 0, means usually the standard is the 8-bit, so we will take like that. We can take even 6 down to 0 also. We can take as ASCII is 7-bit value, and the name of the variable is str, that is string. Like that I have taken the name is str, and I am assigning it with the character a. Okay, this is not required as of now, and I am assigning it with character a, and we are taking initial block. Initial block is required whenever you are printing something or whenever you are assigning any values. For that, initial block is required. Now we are displaying the values. What values we are displaying? For displaying any character or any string, you have to use the access qualifier as %yes. This is called as access qualifier. Means for decimal we have %d, for hex we have %h, for binary we have %b, like that only. For string we have %yes. So for printing this character we are using this %yes, and we are using the name of the variable. Let us print and see what it is going to display. So it is displaying whatever the character we have given. For example, if we give b, so it will display b. So whatever we are assigning here, that value it is going to display. Okay, now what we do is we will do something in display statement. What we are doing here is we are giving %d, %0d for truncating, because see, an integer, the decimal is nothing but it will print the integer value, and integer, as we know, it is a 32-bit value. So it will give some space before printing, that's it. Means the extra zeros will be there. For that it will take a 0 extra. That 0 will not be printed. Instead of that, some space will be printed. If you give 0, it will truncate the zeros which are not used, and it will print the value directly. That we will see. So now focusing back on this code, what we are doing here is we are printing the same character, but we are printing as a decimal value. What we did here is we are just printing the string as it is, means as a character we were printing. In the next line here, what we are doing here is we are printing the same character but the value in decimal. Let us compare what it prints with our ASCII table. Let us print now, or let us execute the code now. Yes, it is printing 97. You can observe the space here. Let us just give 0 here, so that it can truncate the unused zeros. Let us execute. Yes, you can see the space is vanished. Not magic. It just truncates the zeros. So we just saw the magic of 0 here. So yes, it is printing 97. For the value A, it is 97. Let us, yes, for value A, it is 97. Let us take for H. H is 104. You can see here for H, it is 104. Let us just check what it will print for H. Okay. Let us execute. See, for H it is taking 104. 104 as decimal value. And I said one more thing. What happens if we give some larger string? Let us give ABCD here and we shall print the value. What it happens, let us see. See, it is printing only D, and for D it is 100. 100 means A is 97, B 98, C 99 and D is 100. We can compare here. See, D is 100. Okay. So what is happening here is it is just considering D as I said here, and it is not considering rest of the values will be truncated. Same thing is happening here. It is considering from the LSB side and it is truncating rest of the values. What happens if we give 27 here? Let us see now. So if we observe here, only 3 characters are printing and A is not printing. See, even though we calculated like for 7 bits, 28 bits are enough to print ABCD. But why this A is not printed? Let us do one more thing. Instead of this 27, we shall give 31. See, now it is printing ABCD. So the thing is, whenever there is a single character, this Verilog is considering it as 6 down to 0, that is nothing but your 7 bits. Whenever there is a single character, this Verilog compiler will consider it as 7 bits. But whenever we have a group of characters, like we had here A, B, C, D, means whenever we have group of characters, the way these characters will be stored will be in terms of 8 bits. That we need to understand. Means even though we said like 27, theoretically 27 down to 0 or 28 bits are enough to store 4 characters, but practically whenever Verilog compiler stores that value to a variable, it will store in terms of 8 bits per character. That's why when we gave 31 down to 0, it took 32 bits, that is 8 bits per character. That's why we were able to see the complete value here. What happens if we give some 30? Let us see. 30 also it is 29. So it is printing something like, okay, for the first character it is taking 7 bits and for the rest of the character it is taking 8 bits. How means if you give 30 down to 0 instead of 31, total 31 bits will be there. So still it is printing complete values. So what it is printing is, for the first character it is taking 6 down to 0 and for the rest of the character it is taking 7 down to 0. That is, for the first character it is taking 7 bits and the rest of the characters it is taking 8 bits. What happens if we give 29 means, see, This is what is happening. We are getting an exclamatory mark, that is our 33. Value is 33. That value we are getting for this. Instead of this 97, we are getting 33 because the digit, the MSB is truncated. So this is how we can this is how we understand how the number of bits or how the bits are assigned for these values or these characters. So for safer side, for each bit we shall consider 8 bits, so that there should be no confusion for us also and for compiler also. So this is how we use strings in Verilog, because we do not have anything such as string data type in Verilog, which is inbuilt data type in system Verilog. So we have to use reg only with width based on the number of characters we use or we assign to the variable. We shall just check with the arrays also. So if we have array here, and we are taking 2 locations. We have taken 7 down to 0, we can take 6 or 7, anything, and we are taking 2 locations, and yes, we are like string of 0. Oh, this is a, okay, let us take it as string. Okay, str of 0 for means 2 locations, means the name of the locations will be 0 and 1. We are giving compact type of declaration here. So 0 and 1, for 0th location we are assigning A, for first location we are assigning B. So whenever we are printing, you have to use for loop here. So if we use for loop, don't worry about the code as of now, I repeat, and we shall comment it out here. Comment, you have to use 2 front slashes. So we are just printing it here. Let us print and see. Error, why error? Okay, I had to uncomment this. Okay, in Verilog it will not take this I automatically, but in system Verilog it will take automatically, or we can declare it like this here in system Verilog, but in Verilog it is not possible. Okay, now it will work. Yes, it is displaying A and B because we are giving %s. If we give %d, it will print 97 and 98. So this is how we can print, or this is how the values will be taken. This is about the string. So we just saw how we can assign the value to the string in Verilog, because in Verilog we do not have built-in or implicit string data type. So we have to take reg and we have to declare the width, and based on that width we have to assign the string or the characters string value in terms of characters to the variable which is taking that value. This is for today, and from tomorrow we'll start like loops we can start, or okay, let me see what we can start tomorrow. So after that, once we start with loops, and then we finish function and tasks, and later on that we will start with the coding. And for that coding I'm planning, like along with the design, or means digital electronics, in the DE we will do the design, and the same thing we will port it as a code, so that you will understand both design and coding, means design at the circuit level and coding at the and design at the code level also. So please so this is the end of the video. So this, after the long time I just came back. I'm really sorry for that. I was quite busy. I just assured you in my last video that I will not take any breaks, but from now onwards I will not take any breaks. I try my best to put all the videos on daily basis, including weekends. So yes, please like, share this video and subscribe to my channel for such more updates. Thank you so much.